Hey folks, glad you're joining us for this kick-off overview of Wheeler's teachings. We're diving into some of the most practical wisdom about data and quality, drawn from a stack of documents by Donald Wheeler.
Yeah, it's pretty cool to start with someone who has spent years simplifying the whole idea of process control, measurement, and data analysis. We'll be pulling from his articles and columns, which cover everything from experimental techniques to real life case studies.
Exactly. The main goal here is to lay a solid foundation for understanding what Wheeler is all about. We'll talk predictability, measurement, homogeneity. Basically, why you shouldn't just chase numbers or trends blindly.
Right, and it's not just technical mumbo jumbo. Wheeler's focus is on giving anyone the tools to see signals in data, communicate those discoveries, and just make better decisions at work.
So buckle up as we unpack what makes data meaningful, when it's actually useful, and how charts and simple techniques help you sort out the noise from the real story. To kick things off, let's talk about Short's approach to observational data. Wheeler points out that most data comes from real-world operations, not fancy experiments. So the key question is your process predictable or unpredictable?
Predictability sounds obvious, but when you look closer, it's all about whether your process is running up to its full potential, without surprise disruptions. If you don't control for the big causes, you end up with spacey charts and wild swings.
Exactly. He uses charts to help you spot when something big is sneaking in and messing things up. Like if you see points outside those 3 sigma limits, that's your cue to investigate.
That fits right in with Wheeler's 6 ANOM techniques. The original analysis of means, or ANOM, compares treatment averages to a grand average. It's super handy for experimental studies when you want to see which group stands out.
And there are other flavors, right? Like ANOR for checking variance, ANOMI for factor effects, and ANOX to test if supposedly similar values are actually homogeneous. The big thing is using scaling factors, so you're not just guessing about what counts as a signal.
Yeah, speaking of signals, short-run SBC charts like the Z chart or difference chart come up when you're switching products often. Instead of mixing apples and oranges, you transform data so each product's outcome is compared to its target and variation.
You can't just standardize with global statistics unless your data are totally homogeneous. That's one of Wheeler's pet peeves. It buries the meaningful signals and squeezes the chart. Always use within subgroup statistics.
Measurement is huge for Wheeler. Like when checking if 8 instruments are truly equivalent, he uses ANOMMR or analysis of mean moving ranges. If one instrument stands out, recalibrate, but only if the chart shows it's worth doing.
Right. He's big on consistency charts. You shouldn't mess with calibration unless your chart tells you there's a problem. Needless tweaks just add more noise. It's like putting salt in your coffee and thinking it makes it better. Totally counterproductive.
Now, about capability and tolerance ratios, Wheeler sort of flips the script on traditional approaches. A high precision to tolerance ratio is nice, but it's only part of the story. True capability is when you combine the ratio, process location, and the interclass correlation.
If you just look at numbers, you miss out. It's the process behavior that shows if you can actually deliver quality, not just whether you hit a target or keep things tight. Prediction only works with processes that are predictable.
Homogeneity. This is another big Wheeler concept. He's skeptical about classification schemes that sort data into neat groups. Just because something is similar doesn't mean it's homogeneous. Always check for noise, and if you don't find differences where you expect them, maybe your grouping is off.
And sometimes it's better to let the process tell you what matters. Extended monitoring, input and outcome charts, fast studies, all these let you see every factor at play instead of relying on one factor at a time or complex experiments. So, to sum it up, Wheeler's teachings say, don't just chase trends, use charts, focus on homogeneity, and let the process tell its story. Approach measurement, calibration, and quality as hands-on, ongoing discovery.
That's the heart of it. Thanks for tuning in. Keep an eye on the signals, not just the numbers, and let data actually speak.